Linear regression is a bit like the Lord of the Rings movies. It comes to you in 3 parts. Part 1, how does it work? Part 2, how well does it work? Part 3, when or when not to use it. So what is linear regression and how does it work? Well, first you start off with some data, and here's a fictitious example. So we start with the data, and now you can clearly see that this data is following some sort of line. The y-axis indicates what we call the dependent variable. The x-axis here indicates the explanatory variable. As the name implies, we use one or more explanatory variables to get a dependent variable. Now, what linear regression does is find the line that best fits that data. The line has the form of a linear equation, hence the linear in linear regression. The alpha here indicates how high the regression line starts. The beta here indicates how the explanatory variables we put in influence the outcome. In this video, I will only talk about linear regression using one explanatory variable, but in reality, you will use multiple ones. Now finally, you'll notice that the data isn't exactly on the line, but kind of around it. That's what this error term indicates. What linear regression does is find a line for which this error term is as small as possible. Now, if you want to predict other data points, just look for somewhere around the line. Linear regression is used quite a lot. For instance, a business might wonder what their sales might be in the future. A government might wonder how education spending influences test scores. A social scientist might ask about the relationship between how prestigious a profession is seen and how much income these professions earn. Now let's take a look at this last example and how to do this in LibreOffice Calc. I've already plotted the data beforehand. Prestige is on the x-axis, our explanatory variable, and income, the variable we want to predict, is on the y-axis. Next, we select our data and insert a trend line. Select linear. Give your trend line a nice name. Now, we're going to extrapolate this line forward because we want to see into the future. 10,000 should be more than enough. Finally, let's show the equation and the coefficient of determination. I'll explain what this means in a moment. So, this line looks nice, but how well does this line fit? What does it even mean to fit a line well? So, this is where the R² comes in. Get ready for some math. In most cases, we use the least squares approach. You take all the errors, that is, the distance from your measurement to the line, square it, and then sum it all up. This is what we call the residual sum of squares. In other words, it's the part that the model doesn't manage to explain, the error. It's the variation around the regression line. Now, there's also something called the total sum of squares. Basically, it's the sum of the total variation in y values. R² is simply 1 minus RSS divided by TSS. In other words, if R² is 0, then RSS is close to TSS and our model doesn't explain anything. If R² gets closer to 1, that means that our error is going down and our model seems to be doing a good job. So you want your R² to be close to 1. In our example, R² is about 0.5. So this regression line explains actually quite a decent bit of data, but we can probably improve this line by adding more explanatory variables. But is linear regression the right tool for this job? So linear has a few assumptions, but I'm only going to name 2 of them. The first of them is normal data. Linear regression assumes that the data has a normal distribution around this regression line. So you've got to watch out for skewness, multiple modes, or heavy tills. The second assumption that linear regression could make is unequal variances. Linear regression assumes the data all has the same variance. Now, the mean, of course, follows the regression line, but the variance around it should stay the same. You can visualize it as kind of a normal distribution around the regression line. So a megaphone like this is forbidden. So, in conclusion, linear regression tries to find the line that best fits your data. It tries to model the relationship between a dependent variable and one or more explanatory variables. If you want to know how well this works, just look at the R² value. The closer it is to 1, the better your model explains the data. Finally, be careful in using linear regression for data that isn't normal or of errors that have unequal variances. In these cases, you might have to do some more work or consider a different approach. That's linear regression in a nutshell, and, if you have been, thanks for watching.